So let's start with what's on the spec sheet under what we call the teal small parameters. Not in any specific order, but we'll start with what we call FS, the resonance frequency. And this is the frequency at which the loudspeaker mechanical system will resonate. If you just think of the string on a guitar, the different size strings and the different tension, you have a resonance. And this is what we're referring to with the loudspeaker. If you recall looking at an impedance curve, we will have in frequency, in hertz, and an amplitude in impedance. At some frequency, we will have a peak in the impedance curve. And this is a resonance defined by the mechanical system, which includes the mass and the stiffness of the compliance. Next is RE. This is the DC resistance of the voice coil. It is sometimes written on a spec sheet as DCR or RDC, and it is simply thinking of the voice coil as a resistor. It's just a measurement of the DC resistance across the coil. Next is SD. SD is the surface area of the moving part of the loudspeaker. So we know that the speaker has a frame and the surround is glued to it. The surround is attached to a cone. And to calculate SD, we'll typically take half of the cross-section diameter. By half, I mean half of the surround, not all of the surround. And the area of the cone, calculate this for the surface area that is moving. Next is CMS, which is the compliance. This is the stiffness of the cone and when we have a spider attached. How springy is it? What is the stiffness? And the word compliance, it is a reciprocal of stiffness. If you think of a spring, the compliance is how loose is it, or opposite, how stiff is it? How much does it push back? MMS is the total moving mass. I'll insert MMD, which is the static mass of the parts that can move. That is, if we could take them and put them on the scale, typically we'll take half of the surround, half of the spider, put it on a scale, that would be the MMD. The total moving mass also includes mass applied by the air that the cone interfaces with. So if you think of the fact that air has mass, that mass is actually putting a resistance, a pressure on the cone. So the total moving mass is the mass of the stationary part, or sorry, the moving parts when they're stationary on a scale, if you think of it that way, and then add the air load for total moving mass. Then VAS is known as the equivalent volume for the spring of the compliance. And this is made up, if you think of the air load on the surface of the cone, and if you made a box with this surface and you had created a spring to push back, how much air, how much compression would equal the compliance of the moving parts of the loudspeaker. And we'll get into more details on these later on in other videos. Next will be a few more things on the teal small parameters.